Okay. Okay. So we're gonna be focusing on React hooks. I prepared some examples that you can download and run. You can see the link in the chat, and clone it, install the dependencies, and run it in your local browser to test out the various examples, so that in case you wanna mess with the examples, you can. So let's talk about React hooks. I know a lot of you are already familiar with it. You've been using it in the app that we're building. Okay. So one thing about hooks is it's extremely well documented. So I recommend reading through their official documentation. It's really well written, and in particular, if you already had some experience with it, I recommend that you read the hooks API reference, as well as the hooks FAQ. Both of those things will help you get an even deeper understanding of everything. So the first thing I want to cover is why use hooks. Hello. Okay. All right. Can you hear me okay, by the way?
Yeah.
Okay. My computer feels a little sluggish, so I wasn't sure. Okay. So why use hooks? So this is based on the documentation. I took these 3 reasons directly from their documentation, which you might have seen before. And the problems that they were trying to solve is specific to React. So there's sort of React pre-hooks and React post-hooks. And before hooks, you would write React components in terms of classes, and that's what most people were doing. There's also the Redux, which is kind of another story, but let's focus on the class-based version of React, which I believe probably before hooks, that's what most people were doing, and they sort of experienced these problems. So they found that it was hard to reuse stateful logic between different components. And because of that, partially because of that, the components that are complex, they become hard to understand. And they also mentioned that classes are confusing, specifically because of some quirks of JavaScript, such as having to bind a method if you want the method to be usable as a event handler. So because of that, they sort of came up with this hooks idea. And if I were to summarize hooks with just one sentence, I would say hooks is basically a mechanism by which you can write React components with no classes. So sort of classless, or you can think of it as classless React. And I don't think they are saying that classes are bad or counterproductive, but rather that in the way that, compared to the way they utilize classes in React, they think that hooks is an improvement. And in React, in the class-based React world, they were using classes in a very specific way, that certain things about how the class was constructed was tied to how React worked. So some of those limitations were sort of built in a React specific way, I would say. So they're not entirely saying that classes are bad, I think, based on my reading of it. Okay, so that's the motivation behind hooks. I want to go to this slide first. So the design of hooks is based on this idea that they give you a set of native built-in hooks, which we'll look at some of them. If you want the full list, they are in this hooks reference guide. This is more or less the full list. I think there might be like 2 or 3 in addition to these that are in the docs, and they are planning adding maybe a handful more. But essentially, the full list of the built-in hooks should not be gigantic. It should be like a tractable number of built-in hooks. And the idea is with these built-in hooks, you can build larger blocks on top of them. You can combine them, compose them, etc. And one of the promises of hooks is that it's a more composable solution in terms of code reuse than their class counterpart in React. I want to talk about how hooks work internally, but in order to talk about that, we want to understand how the React rendering engine works. So a simplified view of it is this. So whenever React needs to render the DOM, it does these 2 things. It first calls your component's render function, which might either be a method called render, or if you are doing a functional component, then it's just the function that you're using. That is the render function. Calling this render function gives React a virtual DOM. Oops, I did not mean to do that. Okay, gives React a virtual DOM, which is a representation of what the sort of DOM elements that actually show up on the page are, but are not the actual DOM elements themselves. And then after that step, it syncs this virtual DOM to the actual DOM in order to render it. So when that happens, so this arrow, that goes to the actual DOM, and when it's sort of materialized in the actual DOM, the DOM can send you user events such as like mouse clicks and keyboard events, etc. And those things can set off a set state function telling React that something that your view depends on, some state that your view depends on, has changed, and that's the thing that triggers a re-render. So this is a simplified view of how the React rendering loop works. Let's call it React rendering loop. A slightly more complicated view might be, where is that? Oh, I didn't put that here. Okay, a slightly more complicated view is, well, the render process happened in this tree structure because you have a parent component has child components, and so forth. And parent component is communicating to the child components by first passing props down, and also props. And also the parent component is controlling the child components in terms of when the child components get rendered. So because of that, part of this arrow that syncs the virtual DOM to the DOM, part of the things that happen is the mounting of new components sometimes need to happen because a parent needs to, based on the updated state, the parent realized that new child components need to be rendered and that the mount event happens for the child component. Another thing that can happen is due to the updated state in the parent, the props that are passed to their child components are modified. So another thing that can happen is the prop updates. The props get updated. And these things actually also goes back to trigger a render as well. Trigger a render of, or sort of like a re-render of the children. So those are the things that you need to keep in mind. This big high-level picture. And what React hooks does is basically allow you a way to hook into the various points in this rendering loop. Okay, so to give you examples, when you use the UseDate hook, the UseDate hook hooks into this setState trigger point, so that when you say UseDate, you get this set thing function, and every time you call the set thing function, you're hooking into this setState trigger point that can potentially cause a re-render. So another thing you hook into when you use UseDate is inside the render function. You're also hooking into UseDate because you're asking for the current value of the thing, and you're utilizing the value of the thing inside your render to generate the virtual DOM. So UseDate hooks into this part and this part. What about UseEffect? Well, UseEffect hooks into this. Effects are executed after this syncing the VDOM to DOM has already happened. So, and UseEffects. So actually, since I wrote down mounting and prop updates, so maybe I should say, hey, UseEffect actually hooks into this part. Whenever mount events happen, or whenever prop update events happen, that's when UseEffect happens. So UseEffect is a hook that hooks into this part of the rendering process. What's another example? Maybe use context. So use context is use context again hooks into the render function, because when you say use context, you get the current value of that particular context and you use it inside the render function. But use context also hooks into this mounting sort of event, I believe, because the context is passed from, like, the context is a sort of basically saying, when I want a context around this parent node, I'm saying all of its children and all of its descendants have access to the same context. So all of these guys, and even the sub children, my grandchildren as well, have use of the same context. So I believe what's happening is whenever this mounting occurs, there is some automatic passing down of the context as well from the parent to the child. So use context is hooking into this render function part of, as well as the mounting part of this loop here. So that's the mental model of how hooks work. Does anyone have any questions or comments about this picture? No? Okay. So the next thing I want to do is make some analogies between the React hooks universe. Actually, one thing I want to say about React hooks and how they are sort of messaging this change to React developers is do I need to rewrite all my class components? So for the people who are using classes from React, should they all rewrite everything? They're saying that you don't have to rewrite everything if you're not planning to make any changes. Just write your new code using the hooks system, or if you're making significant updates to an older component, that's when you want to consider rewriting it to hooks. So it's like they're recommending a gradual migration, but it feels like in the future they're really planning to go all in with this hooks approach in lieu of classes. Okay, so now I want to make some analogies between React hooks, the hooks-based React programming versus Angular. So UseDate is equivalent to me. It's equivalent to the instance variables in a class that are tracked by a template. So if you're gonna declare either an input or just a instance variable inside a class, and you're gonna use that inside of a template, in React hooks, you should use the UseDate hook to track that information. You should use ref. This is what they recommend. You should use ref if you want to make a variable that's not tracked by the template. And the key difference is if you use UseDate and you make a modification to the state, that's going to trigger a rerender in React. Whereas if you use ref, modifications to the so-called ref will not trigger a rerender in React. UseDate, in UseDate, it's possible to use a lazy initialization function. Give UseDate, instead of an initial value, use a lazy initialization function in the case that generating that initial value is expensive. If you did this, it'd be equivalent to if you want to lazy initialize some instance variable in the class in Angular. So like you initialize it in the class, but set it to null, but then you have it might be we do this with observables often, where there's an observable that we want to set up, but initially we just initialize it and leave it as null. And the first time somebody asks for it, that's when we'll initialize it and then we return it. So UseDate with a lazy initialize function is equivalent to that. Okay, use context. Use context in React hooks is equivalent to scoped injection in Angular. Scope injection in Angular, I believe, looks like someone might need to correct me if I'm wrong. Like, I believe scope injection is like you have a component in Angular. My component, blah blah blah, and you list a provider, I think, to some service. Is this true?
Yeah, that's accurate.
Okay, so when you do this, this is called, I call it scoped injection. Anyway, I think that's probably the accurate term for this. But what happens when you do this is that there's instead of this some service being a global singleton, there's a specific instance of some service that is the singleton, but only within the scope of my component. So and the descendants of my component, which means that if I use my component somewhere in the app, there's a specific instance of some service that this my component uses, versus if you use it again, there's a separate instance of some service given to the other instance of my component. But the extra thing you get is that all children or grandchildren or all descendants of this component will also get access to some service. So in Angular, that's what I call scope injection. And when you think about use context, it should be used in the same use cases as you would use scoped injection. Use effect. Use effect is a very important one because it's very frequently used, and I equate that to the combination of ng on init and ng on changes. We'll talk more about that. Use memo is a memoization shorthand, and I equate that to share replay when we're using RxJS. Like when we're building up a RxJS pipe that perhaps has one part of that pipe is a expensive calculation, and we don't want it to recalculate once for every subscriber that you have. We use share replays. For the same reason, we should use memo. And then I also mentioned refs. These are DOM refs. This is not to be confused with useref. They are not to be confused with useref, but refs or DOM refs in React. You use those when you need access to the native element. And then finally, I would say, roughly speaking, when you feel that you need to extract something into a service in Angular, in the React hooks world, the solution for that is custom hooks. Although there are more than one way to do this, there's various approaches, and in addition to custom hooks, you can also consider using helper functions or helper classes, but I won't go into too much depth into that in this presentation. Okay, with that, I think I'm gonna go into some examples that I prepared. Do you guys want to ask me anything or comment on anything before I do that? Okay. All right, let's do it. Okay, so if you downloaded my examples and you ran yarn start, and then this is the example app that you should get. So all the examples are in this EX folder under the source folder. The app.tsx is the sort of top level of the app, implements this little select box, as well as rendering the component that you've selected. So you can sort of select a different example and it'll render it on the page. So I'll start with a simple UseDate example. So when you do UseDate, you're setting aside some state, and you're attaching it to a hook, but this hook is sort of attached to the React rendering engine, as we've seen. And so this little bit of state is sort of stored in there somewhere. And when this function, which is the render function, when this function is called, you get these two items. One is the current value as known by the system of this state, and then there's a set function which you can use to update the value of this thing. So the two parts that are sort of hooked into, in one case this rendering function, and then the other case is that set state trigger. The set name sort of pulls that trigger and can cause a re-render. So what happens when I run this is, so every time I modify the value, the name value, I wired it up to call this onChange, and what the onChange does is call this set name. So this means every time I make a change in the text input, it calls set name, which causes a re-render in the event that the value is different from what it was before. So a re-render means it again calls this render function. So every time I update this the value in this field, it actually re-renders the entire component, which is this component. It calls this function again and again, and the next time every single time it calls this UseDate function. Let me show you that. Calling. Okay, so every time I change this text field, has it compiled? Wait. Okay, all right. So yeah, if I simply change just type a keystroke causing the value to change, every time that happens, it has to I will not call it re-render. Well, no, I would call it re-render. No, sorry, I would call it re-render. A re-render, regenerating this entire div. Which seems counterintuitive, because that's a lot of work to do, just for updating the value inside the field, right? So it has to regenerate this whole tree of DOM elements every time, but that whole tree of DOM elements is virtual DOM, it's not real DOM. So that's what cuts down on the expense there, and what React does is actually based on the new version of the virtual DOM you generate, it'll compare it against the last version of the virtual DOM it got and come up with the smallest difference that needs to happen to the real DOM, and that's what it uses to synchronize the virtual DOM to the real DOM. So it that's how it works out. So you should be conscious that this rendering function is potentially happening more than you might think. Okay, let's go to use effect. So for use effect, I'll use this I use this window resize example. So this is an example where this pink box in the middle of the screen is going to automatically adjust when the window is resized. It's a little slow because my whole computer is kind of sluggish right now, but you can kind of see it. And the way that works is using a combination of a UseDate hook and a use effect hook. So let me talk a little bit about use effect. Based on the documentation, you should use effect. Anything that is construed as a side effect that you might want to do within your rendering function should be put within a use effect. So, and a side effect, what is a side effect? Let's talk about that. What is a side effect? Anyone want to try answering? What is... Anyone? What is a side effect?
Something that's not related to the action in hand. Something that's not...
So something that's not related to the action?
Something that's not directly related to whatever the function does. Or to whatever it says it does.
Oh, okay. I would make it more precise there. It's an effect that the function has that aside from its return value, right?
Yeah.
That so something a function does that has an effect other than it's the return value. So examples of that would be console.logs is a side effect because you do that. It does have an effect. It spits something out to the console, but it's not reflected in its return value. This guy is a side effect. Registering an event handler is a side effect because, again, it's not reflected in the return value. In this case, it sort of does, but yeah. But if other than that, if you disregard that, then this line is the effect that this line has is not reflected in its return value, but it has an effect into the rest of the world, as in, well, now starting at this point, every time the window resizes, it's going to call your function, which has an effect. So, and if you hadn't done that, that wouldn't happen. So, another thing I would say is a side effect. Maybe I'm mixing together this in pure functions. In any case, so you should think about that, like whatever. Yeah, I think one one is enough. Let's just focus on that. So whatever line of code you do, you need to consider that. Does this leave a side effect that, like, after I do this and the function finishes, is there something that endures, right? Is there, and if there is, then we want to wrap it within a use effect instead of doing it directly inside this function. So one thing about this, let me just walk through this code a little bit. So first, so initially, okay, I think I need to back up and do it like this first. So if we call useEffect without providing an array, this array is the dependencies, by the way. If we call this like that without providing the array, then this code will execute every time a render happens, which is equivalent to having this code inside of your onInit as well as your onChanges for Angular. And React, class-based React has equivalent things to those as well. So this is going to happen every time. If you provide a dependencies array, however, what it does is it does a change comparison implicitly. Do I have an example of that? So these dependencies are more like ng on changes, where you have you get an changes object. And what these are, like, let's call this array, say, tracked changes, maybe. And if it's an empty array is one thing, but tracked, but if it's like a prop, say, I don't know, names, maybe you have a property in your class that's names, then this like looks through all of the changes and see if, no, not all the changes. It looks through every prop in this array and goes through this changes object to see if there's anything in this array that has changed. And it'll execute this code only if something within this array has changed. So you can imagine like there's like a every loop or some. There's some prop for which changed. Like based on this changes object, it changed. So therefore, if your array is empty, it's like never true that some of them would have changed, and therefore this would only happen ever once if you have an empty array. But if you have say you put size in here and the size happen to change, then every time size changes, then this would happen again. Okay, so so we can print this out. So let's see when it actually does this. Sorry about the wait. Okay, so we called the useEffect callback one time, And in this case, it only happens once ever. So this happens once, and what it does is registers this onResize handler, and we have it wired up so that every time onSize is called, it'll call the setSize callback from our UseDate, which causes this re-rendering. So it will actually re-render, which means calling this whole function all over again whenever setSize happens, which means whenever I resize this window, it's actually going to re-render sort of this whole subtree, but it won't necessarily, again, it'll try to make the cheapest DOM modification it can based on the differencing of the virtual DOM. Now this cleanup function is important because it'll allow you to clean up with the API of useEffect. You have the option of returning a cleanup function. That's just the contract, that if you return a function to useEffect, then it will call that function when it is time to clean up. When is it time to clean up? Well, there's two situations. One is if it happens so that the content of this callback needs to be called again, such as based on your dependency array. So if you put some properties into the dependency array, and one of those dependencies values have changed, it'll call this code again. Before calling this code again, it'll call the cleanup function in the previous round. Or if you didn't include this dependencies array, and the situation is all of this code is called on every single render, then it'll also call the cleanup function in the last round. So essentially, basically, whenever this code gets called and there is a last round, the cleanup function from the last round will get called. So in this case, that makes sense. We register for the resize event, and then I want to make sure it gets removed before the next time, because if we don't clean it up, these resize event handlers will get piled up. Yes. Was there one more thing that I wanted to say? I forget. Okay, let's move on to the next one. I want to show this fetch data example. Okay, so how do you fetch data in a hooks-based React app? This is a simple way to do it. Because fetching data is a side effect that it causes a network request and then some stuff to come back. That network sort of activity happening is a side effect. And after the data has come back, we use it in combination with a UseDate to sort of store the data in a way that the view is going to be reactive to that data. So we do something like this. Let's look at this example here. One second. I forgot to run the server. Okay, let's try that again. Okay, so we fetched some data, and I gave the server a 3-second delay so we can see the loading indicator here. And here it's quite important to have this dependency array. Putting an empty array here makes it so that this code is only called once. If we omitted this array, what you would actually see is this render function getting called over and over again. We're in this infinite loop. And the reason that would happen is without this dependency array, this code happens on every single render. The problem is every single render also causes set data to be called, which again generates another render. So you get into this infinite recursion situation. So whenever you're using fetch data, whenever you're fetching data, you should make sure to provide a dependency array with the appropriate dependencies. In this case, we don't have a dependency because we're making the same API call. In the situations where you have some value that you may need to pass in as a parameter of the API call, that parameter should probably go into this dependency array. Okay, so there's one problem that I'm sure a lot of you have seen if you've done this kind of work with hooks before, which is that if you leave if you unmount the component before this request completes, you get this warning here that says, hey, I can't perform a React state update on a unmounted component. And the reason that happened is if I go to this component and then I leave, I have unmounted that component. However, the fetch is still in progress even after I've unmounted the component, and then I call set data on a state which is part of a component that's no longer there. And although that doesn't break anything technically, React gives you this warning to say, hey, you probably, you have something left over that's not cleaned up. You probably want to take care of that. And a common way that I've seen people solve that is by using a little flag like this to say, hey, if you unmount, you're gonna call my cleanup function, right? Because I can return to use effect a cleanup function, and I can say, hey, if you call my cleanup function, I'm gonna flip my flag, and then later on I can say, oh, if my flag has been flipped, I'm not gonna call set data anymore. And this does solve the problem. And you're gonna get rid of that warning because you won't be calling the set data after the unmount happens anymore. So I've seen this pattern, and you can probably, if you want to use this pattern, you can make a custom hook that does this for you automatically. I think we do have something like this in the auto wash code base. I want to show you another approach to doing this though, which is using the fetch request cancellation. So the fetch API, if you are using the fetch API, there's actually a mechanism with which you can cancel an API request. And then in the network panel, you can actually see that request being canceled, and I would assume that has the effect of like actually canceling the request, as in if it started getting sent out and is not fully sent out, you can actually stop it in its tracks. And the way you do that is by you create a board controller and you connect it to this fetch call using this signal parameter. You say, hey, when use this. I don't know exactly how this works internally. I just know that you pass a signal function to the fetch, and the value of the signal function should be the signal method of the controller that you've created. And once you've done that, later on, whenever you want to cancel that request, you call controller.abort, and that will cause this fetch request to cancel. So let me show that to you. So now if I switch over to another example while the request is going, it'll actually cancel that request. Let me see if I can see that. Although my thing is kind of slow. Let me try that one more time. Oh, it's this one that I want. Okay, so here it says the user aborted a request, which is so what actually happened is when you call controller.abort here, it actually causes this original fetch call, which you were waiting on. It causes that to throw an error, which is why I put a try-catch block here. So without this try-catch block, you actually see this error on the console. You say, oh, this fetch aborted with an error. So I chose to catch it and then print out a warning. So this is another way you can handle this kind of situation. And again, if you like this pattern, you can extract this out into a custom hook. Any questions about that? Okay. So seeing that we're running low on time, so what I would like to do is extract a couple of these examples that I've already shown into custom hooks. So custom hooks are sort of hooks that you can make yourself. The idea of well, what is a custom hook? A custom hook has to start with the word use to follow their convention. I believe their system even insists on that naming convention. If you don't call it use something, they will barf at you. But a nice feature of hooks that makes it easy to reuse code is that if you come up with something like this, like a pattern like this that works for you and you've tested, it's actually very straightforward to extract that out into a custom hook, which can in turn be reused. So let's just go ahead with this example. So I came up with this pattern of, okay, I'm gonna combine this use effect with this UseDate to make a thing that where I can make a request and then take the data coming back from the request and then put it into the state, right? And then allow the UI to render the updated state. And also, I want it to abort when this component has been unmounted. I wanted to use this cancellation API to do that. So what you do normally is just the same procedure that you use to extract normal functions. This is usually a little bit harder with class-based React because you have to consider what the this variable is bound to. If you extract it out into a separate object, the this is on the other object now, and then so you have to consider, oh, what is this bound to in this case versus that case, and you might have to rewrite the this in some cases correctly. With this classless approach, you never mention the word this in any of this code. So and all of the React hooks based code do not mention the word this. So all the names, all the variables names that are used are like regular variables, either consts or lets. So therefore there's less ambiguity there. So So this is just like how I would normally extract out functions for reuse. I would copy this block and then wrap a function around it, wrap a new custom-made function around it. I'll call it use something because that's the hooks convention, naming convention. I'll say maybe use fetch data, and then I'll drop all of this code in there, and then I will reread the contents of this code to and look for things that I might want to make a parameter of this function. So first obvious thing is this URL. I probably want to make the URL a parameter so they can use this tool with a different URL endpoint. This stuff don't really need to change. The last thing to consider is what things I want to return to the user, and I believe that is just the data, if I'm not mistaken. TypeScript wants me to give this a type. Okay, so I'll do that. URL should be a string, and I believe that's all I have to do actually. So you can see like that requires very, very minimal transformation of the original code. All I did more or less is change the hard-coded URL to a parameter. And I believe everything else kind of, and I added this return statement. I determined like what does the user of this hook need to use in their use case. And I think that's just only the data. All of this messy cleanup and abort controller stuff, the user actually doesn't have to know about that. So now I'm gonna swap in my hook. And replace all of the existing code with it. And let's see if this still works. Wait for it. It's still compiling. I'm running too many things on my computer probably. Okay, I think it compiled. I'm gonna reload the page just in case. Go to that data fetching example. Yeah, it loads the to-do list, and I'll try switching away from it while it's still loading, and I see this warning that says user aborted the request. So I'll say like this is the biggest strong point of React hooks for me, is the ease of extracting code into a reusable function. Like you can get the code to work in your scenario first, and while you're doing that, you just do anything you need to get it to work first, not worrying about the reusability of it. But when it's time to make it reusable, it's actually very painless. Yeah, so that's what I would say about React hooks. I am planning to do more future talks